Okay, hello, welcome to the channel. My name is Victor. I'm going to be your anchor for this series. So this is the data analytics roadmap. We're trying to do a 7-part series where we're going to look at who is a data analyst, how can you become one, what are some of the concepts you need to understand, you need to learn, you need to know if you want to become a data analyst. We're also going to dive into some aspects of machine learning AI. Now, data is the new oil. So many people will say, okay, if I want to become a data analyst, what do I need to know? How do I learn? What do I get started with? And all of that. So we're going to try to look at some of the things that you need to do if you want to become a data analyst in 2025. So I'm going to be looking at this roadmap sheet, and I'm going to be explaining different aspects of the roadmap so that if you're interested in doing data analytics, you know what do you need to learn, what skills do you need to acquire, and all of that. Now, these are some of the things you want to do for a data analytics role. Now, you want to build a very strong foundation in Excel, right? Now, most of the times, your data is going to come in, let's say, just a second. Your data is going to come in Excel. Your data is also going to come in CSV file. Your data is also going to come in, let's say, an SQL file format. Your data is going to come in different formats. But most of the times, you're going to have an Excel sheet for a beginner to start doing your work, right? So that's why it's very important for you to build very strong foundation in what? Excel. So one of the very first tools you want to learn as a data analyst is to know Excel. Either you're using Microsoft Excel, or you're using spreadsheets, any spreadsheet software. Google have theirs, right? The kind of things you want to do is that you want to be able to do analysis. You also want to be doing reporting. So there are two things. Now, analysis, if you have a data set, let's say an employee database, so it has ID number, it has name, it has gender, it has salary, it has department, it has, let's say, grade, level, it has all of those data. So you have 1, 2, 3, 4, 5, 6. You have up to, let's say, 10,000 employees. Now, can you analyze this data and bring some insights, some kind of intelligence? That's the job of a data analyst. Then at the end of the day, you want to be able to report this in different formats. You want to be able to report it and do some presentation with respect to this data that you have analyzed. And to do that, you need some functions. So you need to be able to do conditional formatting. For instance, you want to say, if a particular salary range is between $50,000 per year to, let's say, $100,000 per year, select them. So you want to select all the items in the entire sheet if the salary of the person is between this and this. Another thing, you might just be getting, out of the 10,000, you might be getting, let's say, 2,000 persons, right? So to do that kind of analysis, you need if functions. Then date if, then you have VLOOKUP, vertical lookup. You also have horizontal lookup. You want to be able to replace item and substitute them for something. You want to be able to do upper, lower, proper. You want to be able to do concatenation, that is like joining two things together. Let's say I have first name of the employees, I have their last name, right? Now, and you want to create emails. The email or the website of the company is ctlhub.africa. If you have this as the website name, let's say the first person's name is Victor, second name is Chidi. Now you want to create an email. Your email is typically going to be something like this: Victor dot, let's say, Chidi, right, at ctlhub.africa. Now imagine in this entire sheet of 10,000 rows, how do you automate creating an Excel sheet or a table that have all the email of all the persons in the office? So their first name, concatenate it with a full stop, with their second name, then add a constant, ctlhub.africa. So that's where you use this kind of function concatenate. Then trim, let's say you want to take off the last name, you want to take off the last letter, you want to take off, or you want to work on just the first 3 letters. All of those kind of things are things you should be doing in Excel, right? You want to do sum, you want to count. You want to count how many persons are in a particular column, how many persons have a particular age, grade, all of that. So these are some of the functions you want to be learning when you're doing Excel. Then you also want to understand data. Data is very crucial because, and data is going to come in different formats. Now, in the realm of data analysis, understanding some key concepts is very essential. Now, there's also what we call the data science process. If you check my channel, you're going to see, I'm going to drop a description. You're going to see a list where I talked about the entire data science process. So in talking about the data science process, I talked about collecting data, right? You have to collect data. Once you've collected data, the next thing you want to do is that you want to what? You want to clean the data. Once you've cleaned the data, the next thing you want to do, you want to do some kind of transformation. At the end of the day, you want to start visualizing, then you want to start doing some kind of analysis. And at the end of the day, you want to do your report. So this is what you classify as your data science process. So anytime you get data, you have to first collect it. And even before you collect the data, you have to do some kind of objectives definition. You have to define your objectives. You collect it, you clean it, you transform it. Let's say you collected people's age, or you collected people's gender, you collected their height. And let's say their height, some people submitted in centimeters, some people submitted in feet, some people submitted in, let's say, meter. You want to have a standardized kind of height. You want to have a standardized kind of age. Some people might submit their age in, let's say, month. You want to have it in year, nearest whole number. So those are the kind of things you're going to be doing in transformation. Then, of course, you want to visualize. That's where you want to do things like pie chart, bar chart, pivots, all of that. So those are some of the key concepts you need to understand about data. You want to know how to collect, clean, explore. So we call this EDA, exploratory data analysis. I call it again, exploratory data analysis. So those are some kind of things you want to do at this stage. Then, of course, you want to visualize it, and you want to do some kind of statistics and analysis, or statistical analysis. So here you want to start doing things like frequency, things like mode, things like median, and of course, some measure of central tendencies. You want to be able to do some of these things. Then, of course, machine learning. Let me explain machine learning. Anytime you have data, right, huge number of data, with time, you might want to get trends. You might want to get some kind of patterns. You want to see if there are patterns. You want to see if there's some kind of correlation or relationship between, let's say, if I have age on a data and I have my score, you know, you're going to have 50 years, 30 years, 25 years, 10 years, 32 years. Then you're going to have score, let's say 99%, 30%, 20%, 5%, and all of that. Now, in correlation, we want to see whether there's a relationship between people's age. We want to see a relationship, whether there's a relationship between people's age and people's score. Do we say that the way their age is increasing, they're going to have more scores, their intelligence, kind of? So that's what you look at in correlation. So that's machine learning. For patterns, you want to see whether there's some kind of, the data is in a certain way, or then in trends, you want to see whether, according to time, whether there's some kind of sequence. Now, for trends and patterns, one way you can do that is to do what we call some charts, right? You can do some pie charts, right? You can do some bar charts. You can do some histogram, right? So this is what you call a time series. So if you do your chart and you have something like this, you call this a time series, right? So it can be year, let's say 1995, 2000, 2005, 2010, 2020, right? Then you have some items, some data, right? So this is what we call time series. So you can tell if there's some kind of trend, what we call trend analysis, when you do that. Then for relationship, you want to do some kind of scatter diagrams to see if there's a relationship between this item and this other item, right? So these are some of the kind of things we are going to be doing in machine learning. If you've watched the series up to this moment, we typically have machine learning, data analytics training, mentorship group every month. So if you're interested, you can fill the form in the description below and join the session. On the channel, we also have a complete series on Excel, SQL, Tableau. We also have one for Python, for SPSS, and some other tools. Now, if you look at it, you will see that these are very important concepts you need to understand as a data analyst. Then, in terms of what is data analytics, it's typically making sense out of data. That's the job of a data analyst. And for types of data, data is going to come in different types. And some of the way we can understand the job of an analyst is when the guy is doing or the lady is doing descriptive, diagnostic, predictive, and prescriptive. Let me explain each of them. Now, for descriptive, you are asking yourself what happened in the past. If you have data, the question is, you want to know what happened in the past. So you're trying to look back. For diagnostics, you're trying to ask yourself, why did this happen? Let's take, for instance, for sales data, you're trying to say, okay, is it because of the season? If you do a simple trend analysis, let's say this is January, this is February, this is March, this is April, right? This is December. Do we have some kind of spike? So that can help us tell that this is a seasonal kind of product. So that's what you do when you do diagnosis. In predictive, you want to be able to tell the future, because if you know what has happened in the past, you can be able to say, okay, from this trend I have, then I can tell that, okay, so time next year, I'm going to also have that. Therefore, prescriptive, you're going to be asking yourself, how can we make that happen? That's why we say the job of a data analyst is to help C-level executives to be able to make decisions. C-levels, I mean, chief medical director, chief financial officers, chief executive officer, all of those top guys you have at workplace. So those are the kind of analysis that the data analyst is going to be working on. Then another thing you want to be able to do is to be able to do charts, pie chart, bar charts, then do some pivot tables. Pivot tables are typically summary tables, right? They will just help you summarize, investigate, and analyze. So if you have 10,000 rows in your data set, with a pivot table, you can crunch that into just like 5-6 rows. It is going to summarize everything by, let's say, gender, by age, range, by all of that. Now, when it comes to programming language for a data analyst or data scientist, there are two very popular languages that are very essential. So Python and R. The big boss here is Python, right? Because Python is so powerful. And of course, Python is also used to do things like game softwares, web, mobile apps, and all of that. You can use Python even in web crawling, in cybersecurity scripts, and all of that. You can use Python to do typically anything. But when it comes to data analytics, machine learning, it's very, very handy tool. Same thing with R. So if there's two languages you want to learn to become a very good data analyst or a scientist, it's Python and R. And these two guys, they have what we call libraries. So let me talk about libraries. So a library is just some kind of predefined So a library is just some form of predefined functions, right? When I say predefined functions, what do I mean? You know, if in school you say you have an assignment, if they give you an assignment, what you want to do is to go to the library, right? You get some books in a bookshelf, then you copy out some things, adapt it to your assignment, then you submit to your lecturer or to your tutor. And you're going to be marked good. They say 100%, you got it all right. Now, the library provided a framework, a guideline, some set of standards to help automate or to help ease your documentation. So instead of writing everything from your brain, writing everything from scratch, you just use a library. So you say a library, or times you call it a framework. So there are some frameworks in Python and in R that can help make our job very, very easy. You want to do some analysis, and in one line of code, you have done quite a lot. So you don't have to learn programming and learn how to code from scratch, because with the libraries, you can do quite a lot. So you have Python, Pandas rather, that is a Python library that is very good for data manipulation. You have dplyr, that is an R library. You have matplotlib, that is what's it called? That is a Python library. Then you have gplot2. I think gplot2 is an R library. So you can use them to do visualization, to do graphs, to do data manipulation, and all of that. Then let's look at data collection. Let's look at data cleanup. Let's look at descriptive. Let's look at data visualization. Let's look at some data statistical analysis. And let's look at some big data technologies. Now, if you have questions in this session so far, you can ask your questions in the comment section, and I'm going to give a reply. So for data collection, like I said, your data is going to come in several ways. Either a database. So a database is just a collection of rows and columns, maybe from a website, from a software, and you want to analyze that data. It's going to come in comma-separated value files, that's CSV files. CSV files is just a way we can store files, maybe even off an Excel sheet or from a database. Then APIs are just a way to connect two items, maybe on a software. An API is application programmable interface. So if you have a payment gateway and the payment gateway is connected to a software, anytime somebody comes to the website and you click and you pay, the money goes to the website. From the website, it goes to the bank. So what is between the user, the software, and the bank? So is that API, that application programmable interface. It's just like when you want to make a phone call, right, to your lovely wife, if you're married, or to your friend. You have a telephone line, right? Then you have your wife here, you are here, yeah? Then you have your beautiful wife here. So you pick this phone, you call, and it gets to this lady here. You have a restaurant, you have a wait system, you have a cook, you have the kitchen, you have the waiter, right? The waiter and the service system serves as the API. You are here sitting down, you come, you make your order, the waiter collects your order, sends it to the kitchen, collects your food, and serves it to you. So these guys are the center of the both stuffs is your API. So in software, APIs are created to like make some kind of interaction back and forth. So as a data analyst, you might be giving your data maybe in CSV file, Excel sheet, or it can be scrapped from a website. Now, there are some stuffs you also need to understand. You need to understand data cleanup. So one of the things you're going to be doing as a data analyst is to handle missing data. You collected a data set and it has some missing data. Some persons did not enter their age, they did not enter their grade level, they did not do this, they did not do that. So how do you handle that? So there are several standards on how to do that. You can take the average of that. If it's not so much, you can take up that data item so that you don't have what we call outliers. We're going to talk about most of these things in class so that you understand them in practical sense, right? So those are some of the ways you can handle missing data. Of course, at times you can remove the duplicates. You can find the items that are outliers, those things that are very, very far apart. Imagine you taking statistics of students in a university and you see somebody that entered his data as 3 years. So you see that's an outlier, or somebody 150 years. So that's just something that is out the different items. And at times to clean, you might need to do data transformation. Now let's look at some dispersions, measure of dispersion. So you want to look at range, you want to look at variance. All of these at times you classify them as, for this you classify this as dispersion. For this I talked about measure of central tendencies, right? For distribution, you want to tell how the data set is distributed. Is it something like this? Is it kind of skewed? So for distribution spaces, you have skewness and you have kurtosis. Now let's look at descriptive. So I've talked about descriptive. Most of the times you just want to like either in a textual format or in a visual format, you want to tell what is in the data. You know, most of the times when you have an Excel sheet, you can't tell what kind of data you have there except you run some kind of descriptive analysis, right? Then for statistical analysis, you want to test some hypotheses. In testing hypotheses, you want to do things like saying, okay, my hypothesis may be 0. My hypothesis, what's it called? Sorry. Yes. My hypothesis 0 maybe is say people from a particular country are prone to maybe a particular disease, right? Then in H1, you want to now reject what you said in H0. So that's typically what you do in hypothesis testing. In correlation testing, you want to say, okay, is there a relationship between this particular column and this particular column? I gave an example earlier on with age. Is there a relationship, correlation between age and score? Or you want to say, is there a relationship between year and population? So imagine you draw a chart and the chart goes like this. So this is 1985, 1990, like that. This is the population, 50 million, 60 million. So you see, or you see some population, it goes like this. So you see that this is a positive correlation because as the year is increasing, the population is increasing. If it's going like this, right? So we call that a negative correlation, right? Because as the year is increasing, the population is what? Decreasing. If we have a chart that is just like this, everything it's scattered irrespective of the year, so we say there is no correlation, right? So that's the kind of things we are going to be testing when we do correlation analysis. Now let's look at, then we have some tools. If you need to do data visualization, there are quite a lot of tools you can be using. Like for the series we're having in this month, we're going to be looking at Power BI, we're going to be looking at Tableau, we're also going to be looking at Excel, right? So you can also use some libraries in Python, like Seaborn, Matplotlib to do some visualization, or you can use gplot2 in R to do some visualization. So you see, for a data analyst, you need to understand types of data, the kind of things you're going to do. You want to get a hold of Excel. You want to understand the kind of analysis you're going to be running. You want to learn the programming language. You want to know what way your data is going to come in. You want to learn how to clean your data. You also want to understand dispersion, central tendencies, distribution spaces. Then you also want to understand descriptive analysis, statistical analysis. You also want to be able to visualize your data. You want to be able to do different types of charts. In your CV, you should be able to tell your recruiter, your prospective employer, that you can do these things. Then for machine learning is divided into 3. So we have supervised, unsupervised, reinforcement learning. So if I'm to describe them, supervised learning is just where you try to tell the feature by using labeled data. Unsupervised, unlabeled data. For reinforced, you want to try to say, okay, can we learn from what have happened in the time past, right? So for supervised learning, you're trying to say, okay, based on data I have and these labels of the data, can I tell the feature? For our Python classes, we're going to look at some data sets that you can use to actually practicalize most of these things. And you don't just do machine learning and say, okay, this is the result. You must be able to evaluate those techniques. You must be able to evaluate those values you have. If you want to tell us, okay, the population of Africa is going to be so and so by so year, you want to be able to tell us what's the percent of accuracy. That's what you call model valuation. Then you need to understand that there are some popular machine learning algorithms. Algorithm is just a formula. So if I want to be able to tell the feature, there are some kind of formulas I can use. So you have different types of algorithms. You have decision tree, naive Bayes, KNN, K-means, logistics regression, linear regression, and quite a lot of them. You have CNNs, you have RNNs, neural networks, and all of that. Now, let's look at big data. So big data is the next thing you want to learn, including cloud. Like for our data analytics training, we're going to be having this month for students that are the best in class. We normally give a scholarship that is either the Google Digital Cloud Leader for the second runner up, and we're also going to be giving coupons, exam coupons for the Google Data Practitioner certification. The certification is worth $125. So if you want to attend some of these classes and have opportunity to be able to grab these coupons, you can inbox and join the section. So for big data is typically going to happen in the cloud. So you want to understand some big data concept. So anytime you cannot do analysis within just 500,000, 1 million rows of data, that becomes big data. So think about data that is produced by telcos, right? Telcos, telecommunication companies. All those guys, their customer base is like 50 million. So imagine they can't use Excel sheets. So they're going to be using big data platforms. They're going to be using cloud to analyze their data. Think about banks. Think about multinationals. So anybody that is going to do above 1 million rows of data, that person is going to be using big data. So you have stuffs like Hadoop, Spark. Then you want to be able to understand data processing techniques. So if you intend to go beyond data analytics and you want to go into big data, then cloud skills are very crucial, right? Cloud skills are very crucial because most of the times you're going to do all of these things in the cloud. So I think that summarizes, of course, you have optional if you want to go into deep learning. So that summarizes the data analytics roadmap. So if you have any questions or if you want to join any of our training sessions, do well to reach us and you're going to be in class. In the subsequent series, we're also going to be looking at things like big data, how it matters. How do you analyze your data in Excel step by step? How do you do SQL? How do you do structured query language? How do you query data? How do you differentiate? What's the difference between supervised learning and unsupervised learning? What are some of the tools? And you can also check our 3 playlists on the channel to learn more. Thank you very much and see you in the next series.